this is Tucker from the Math and Physics Resource Center at SVSU. In this video, we're going to go over how to find a z-value from an area that they give you. So remember that the area is generally the p-value. So we can take the areas that they give us and compare them to the table to figure out the z-values that correspond with them. So first, let's look at this problem. We have some shaded area to the left of this z-value that is equal to 0.46812. Okay, so since we have an area to the left, that means we can look directly to the tables. So if we have a 0.46812 area, let's find that on the table, 0.46812, right there. So since, again, since the area is to the left, we can just take the z-value straight from this table. So we have negative 0.08. So our z is going to be less than negative 0.08. So the way that this is oriented right here is based on the kind of area that we have. So since this is an area to the left, our z is always going to be less than this negative 0.08. So moving on to example 2, we have an area to the right of this z-value that is equal to 0.82121. So first, in order for us to look at the table for this, we need to find what the area to the left is. So if the area to the right is 0.82121, we can take that and subtract it from 1, 82121, which gives us 0.17879. So this is the area to the left of this z-value, which we can go to the table to find. So 0.17879, we get 0.17879 right there. So here, if we look at the z-value, we get negative 0.92 as our z. So our z, remember the original problem was that the area is to the right of this z, so our z is going to be greater than that negative 0.92. Now finally, we've got an area that's in the middle of the distribution here. So let's just pretend that these two empty spaces are equal to each other in area. I know that they don't look like that at all, but let's just pretend. So if this is a symmetrical area that totals to be 0.64242, what we can do is look at it in two chunks, really. So we need to find this z-value and this z-value. Now, over here, the z is going to be negative, and over here it's going to be positive, but they're going to be the same number because it's symmetrical. So if we can find this z-value, then we've really found this one as well. So let's kind of break this into a half of the normal distribution here. So I just broke this half and took it down here. So if we've got our shaded region as something like this, this is going to be half of the total shaded region. So we can take this 0.64242 and divide it by 2 to make it 0.32121. And now, if we find the area that's not shaded of this chunk, it'll be the same as the area in here. So remember, since we're dealing with half of the normal, we're going to have 0.5 minus 0.32121, which is equal to 0.17929, or 989. 979. Sorry, 979. So this is the area that we don't have shaded right here. Now we can take this, and this will give us our negative z from the original graph that we have. So if we look for 0.17979, we get 0.17. It's kind of in between these two. 0.17979. Did I even do that right? That should be 879. I'm sorry, I can't subtract. So this is going to be this negative 0.92 right here. So our negative z is negative 0.92, which makes our positive z positive 0.92. So this isn't our final answer. Remember, our original question was asking what z values lie between here. So our z is going to be greater than that negative 0.92, but less than the positive 0.92. Because it's between both of those z values, we have to list both of them in our answer. Because if we had just said that z is less than 0.92, we would be including this empty area here, and we don't want to do that. So we have to cut it off on both the left and the right side to get our final answer here, as negative 0.92 is less than z is less than 0.92. So yeah, overall you just want to kind of figure out the area to the left of the z that you're trying to find, and then from there you can work with that and get the final answer. These ones that are just from the left or just from the right are usually going to be easier than the ones in the middle, but you're going to be following the same process for all the different types. So that's about it. Thank you for watching.